Hi there, welcome to this film about atomic symbols. Now hopefully you've recently watched the film about subatomic particles, so you know what particles are in an atom. This film tries to explain to us how we can use symbols to express how many of those particles are in a particular atom. Okay, and hopefully by the end of this film you'll know the difference between the symbols A, Z and X. You'll know what information they give us about subatomic particles and what their names are. Okay, now it's important that we understand, and the last slide will deal with this, that every time you write these symbols, you write them according to a certain format. Okay, so X is written in a normal case, Z is a subscript to the left of it, and A will go as a superscript to the left of it. Okay, so every time we write these three symbols by hand, although it might be different in certain periodic tables, every time we write them, we're going to write them in that format. Okay. Right, well, let's start with an element symbol X because this is by far the simplest one. Okay, if I choose an element from the periodic table, such as beryllium, okay, I might see quite a lot of information in beryllium's box there. Okay, but the letters, they are the element symbol. Okay, so the symbol for beryllium is Be. And you'll notice that every single element in the periodic table, except for the ones they haven't thought of proper names for, right, the UUQs or the UNHs or what have you, okay, all the ones that they've given names to are a capital letter or a capital letter followed by a lowercase letter. Never two capitals, never two lowercase letters. It's important to remember that because when you write formulas, you've got to write them correctly. Okay, so the symbol X just tells us what the element is, and it's always going to be letters. Now the atomic number Z. Right, now remember where this goes. If we've got an atomic symbol, X, Z is going to go down here. And there's a number of different names for Z, but most commonly it's known as the atomic number. Okay, it's also sometimes known as the proton number, and that name I suppose is a bit more useful because it tells us what it's talking about. Okay, it's the number of protons in an atom. And it's absolutely unique to each element. In fact, that's how we define what an element or atoms, what element atoms are going to belong to. We look at the number of protons they've got. Okay, so carbon atoms will always have the same number of protons. Nitrogen atoms will always have 7 protons, right? Because they're nitrogen. Now, it just so happens that for a neutral atom, the number of electrons is the same as the number of protons. But electrons are quite easily gained and lost, and atoms can turn into ions. So it's best if you remember that the atomic number Z is telling us about protons. But if your atom is neutral, it will equal the number of electrons. So if we just take from this periodic table, which has a little bit less detail, it's got phosphorus shown, whose symbol is P. Now, this periodic table has shown the atomic number above it. Okay, but if we're writing it by hand, we're going to stick to the format that is, we're going to write Z at the bottom left of the element. Okay, so phosphorus has an atomic number of 15. That means it's got 15 protons and 15 electrons whilst it's an atom. But if it ever forms an ion, then we won't be able to say that the number of electrons is the same as the number of protons. Right, moving on to the mass number, which is given the symbol A. Okay, so mass number, this is actually the sum of the heavy parts of the atom. And if you remember from your film about subatomic particles, that's the protons and the neutrons. Okay, so this is P plus N, right? And if we want to find the number of neutrons, and we know that A is equal to P plus N, protons plus neutrons, then neutrons, the number of neutrons must equal A minus P. But we know that the number of protons is given by the atomic number, which is Z. So the number of neutrons can always be found by taking A and subtracting Z. So let's just take an example here. Let's take boron. Okay, boron. Remember, we're always going to write these symbols in this format. Boron, symbol is B, capital B. If you think about it, the mass number is always going to be the bigger number because it's the protons and the neutrons. So this periodic table, which has the atomic number up here and the mass number down there, has them the other way right up to usual. So try not to remember them as up or down. Try and remember them as the mass number being the bigger one and the proton number being the smaller one. And what some periodic tables, but not this one, will do is they'll round them to the nearest whole number. And that's what we're going to do for now. Okay, because the number of protons plus neutrons must be a whole number. These are actually called relative atomic masses, the way they're given, and they're slightly different, but we won't worry about that for now. Okay, so boron, mass number 11. We can figure out how many neutrons there are in boron by taking 5, which is the proton number, away from 11, which is the mass number, and we'll get 6. So there's 6 neutrons in boron. Okay. Now if we put them all together, as we say, we've been looking at this common format, so just really to give us another example, let's take sodium as another example, and remembering that we're going to round the mass numbers for now. Okay, sodium's symbol, so we're sticking to this format, okay, with Z bottom left, A top left. Sodium's symbol is Na. Its atomic number has got to be smaller than the mass number because it's only the number of protons, whereas the mass number is protons and neutrons added together. So 11 for sodium. All sodium atoms will have 11 protons and 11 electrons whilst they're atoms, but not once they're ions. And 23 will be the mass number. Now remember, the mass number, A, minus the atomic number Z, gives us the number of neutrons. So this sodium atom has 23 minus 11 neutrons, so 12 neutrons. Very, very important points there. Quite simple maths. Make sure that you learn this stuff. It's so important for your whole chemistry course. Well, this film mentioned ions a few times. It would be a good idea if you could now watch the film about ions so you can get a better understanding of what exactly those things are.